1,000 slides in PowerPoint, so it helps if you ask the questions in the same order that I have the answers. Carbon dating? Okay. Carbon dating, actually fossils are dated by their position in the geologic column. They are not dated by carbon dating or potassium, argon, rubidium, strontium, lead-208, lead-206. None of those matter. A fossil is dated by the position in the geologic column. They're called index fossils. This guy admits it. Radiometric dating would not have been feasible if the geologic column had not been erected first. The geologic column was invented in 1830s. That was taught for 120 years and became accepted as science, and the geologic column doesn't exist any place on the planet. Okay, there is no geologic column. There are layers of rocks. And they're assuming that it's different ages. That's the problem right there. This guy says fossils have been and still are the best and most accurate method of dating and correlating the rocks in which they occur. We go through all kinds of examples on this, but on video 7. The Earth's atmosphere is about 100 miles thick. It is mostly nitrogen, 78%, 21% oxygen, a little bit of CO2 for plants to breathe, and very little radioactive carbon-14. 0.0000765%. This radioactive carbon-14 mixes with oxygen and it becomes carbon dioxide, most of it does, and the plants are breathing carbon dioxide. Now carbon-14 is formed when radiation strikes the atmosphere. The nitrogen, which is the majority gas are up there and here, nitrogen gets bombarded by cosmic rays and it bombards the upper atmosphere, producing fast-moving neutrinos. These neutrinos collide with atmospheric nitrogen, producing carbon-14. That's how it's made. If you look at a periodic table, carbon and nitrogen are right next to each other. Nitrogen is normally an atomic weight of 14 and carbon is an atomic weight of 12. But if the nitrogen gets blasted with these neutrinos, it turns into carbon-14, which is a rare, very rare, and radioactive element. It is radioactive just like uranium or any other radioactive element, and you can hear it as it decays or breaks apart and throws off all the little particles into space around it. Now, carbon-14 is being produced by the sun, or by the neutrinos, by the high-speed radiation, doesn't matter. It breaks back down to nitrogen. About half of it breaks down every 5,730 years. Okay, this is estimated to be the half-life. Obviously, nobody watched it for 5,700 years. But during photosynthesis, plants are breathing in CO2. And so the animals eat the plants and make it part of their body. So you and I probably have carbon-14 in us because at some time in your life, you have either eaten plants or you've eaten animals that have eaten plants. That's about all there is, okay? So these plants are absorbing things out of the atmosphere. They're absorbing the carbon-14. It becomes part of their tissue. It is assumed the ratio of C14 to normal C12 in the atmosphere would be the same ratio found in living plants and animals. If the atmosphere is 0.0000765%, it is assumed plants and animals have the same percentage. That has never been demonstrated, but as a reasonable assumption. Okay. When the plant or animal dies, it stops taking in new C14, so in theory you can tell how long it's been dead by measuring how much C14 is left. This entire process was invented by Willard Libby, Nobel Prize winner for inventing carbon dating, University of Chicago in 1947 to 53. He worked on this, moved to Stanford University. Carbon-14 continues to decay after the animal dies. If half of it's gone, you would assume it's been dead 5,700 years. It can't get any more, obviously, so it's going to go out of balance. Carbon dating is actually a comparison of the carbon-14 in the object with the carbon-14 in the atmosphere. It's a ratio, okay? If it's 0.0000765, it is still alive. If it's only 0.0003825, it's 5,700 years old, etc., etc. The less it has, the older it is. This is how the theory works. It goes from a half to a fourth to an eighth to a 16th to not much, okay? They compare the amount of C14 in the object being dated with the amount in the atmosphere to estimate how long it's been dead. If only half of it has been, if it's only got half as much, it's assumed it died 5,730 years ago. It sounds good, but there are some assumptions that mess up everything. If I told you to fill a barrel with water, but there were holes in the barrel, as you're putting water in, it's leaking out. It's kind of like a checkbook, you know. You keep putting the money in, it keeps leaking out in different places. But at some point, you're going to reach a stage called equilibrium. You'll never fill the barrel past that point unless you speed up the intake or cut down the outgo. The Earth's atmosphere is going to have the same problem. If you took a brand new planet Earth, created it, poof, and stuck it out going around the sun, 93 million miles away, it would start developing C14 from radiation and start losing it to decay. So the question is, they wondered this back in 1950, how long would it take Earth's atmosphere to reach equilibrium? The consensus was it would probably take about 30,000 years for the Earth to reach equilibrium. And then Willard Libby and the boys at the University of Chicago made a tragic mistake. They made two fundamentally, fatally flawed assumptions. They said, well, we know the Earth is millions of years old, mistake number one, so we can ignore the equilibrium problem. They ignored it. Problem is, radiocarbon is still forming 28 to 37% faster than it's decaying, which carbon-14 is proof the Earth is less than 30,000 years old. Or else it would all be stabilized by now. It would be stable in the atmosphere, and it's not, okay? We could talk all day about that. But basically, if an animal is still alive, it should give you about 16 clicks on your Geiger counter. If it's only giving you 8, you're going to say it's 5,700 years old. If it's only giving you 4, it's 11,000 years old, etc., etc. This is how carbon dating is done. I won't have time to cover all of the evidences I have, but I'll just give you a few examples of how it simply doesn't work. Because one good experiment is worth a pound of theory any day. Back in 1949, when they developed it, the lower leg of a mammoth dated 15,000 years old, but the skin dated 21,000 years old. Same animal. It's not working in 1949. 1963, living mollusk shells dated 2,300 years old. It's still not working, folks. 1970, at the proceedings of the 12th Nobel Symposium, they said if a carbon date supports our theories, we put it in the main text. If it does not entirely contradict them, we put it in a footnote. If it's completely out of date, we just drop it. Freshly killed seal, carbon dated 1,300 years old. One part of a mammoth is 40,000 years old, another part's 26,000 from the same animal. We could talk all day about carbon dating, but here's living snails, carbon dated 27,000 years old, 1984, Science Magazine. I don't have time to cover them all, but watch my video number 7, which is why it's out there. 1992, 2 Colorado Creek mammoths in Alaska found side by side. One dated 22,000 years old, the other one was 16,000 years old. They're side by side. 1996, at Berkeley University, they used the most advanced dating techniques they have. They discovered these things that they thought were 250,000 years old actually were 53,000 to 27,000. I'd like to point out, Your Honor, that is still a 96% error. If you think carbon dating proves the age of anything, you need your head examined. Thank you.
I'd like a show of hands of how many understood that. I guess we aren't the only liars here. I have a pamphlet here written by the Institute for